Hello, welcome to our another topical solution series for IGCSE at Maths 0606. In this video, the topic we are focusing on is factors and polynomials. The questions we have picked to solve in this video is from May-June 2011, paper 2-1. Well, as usual, before we hop into the question, let's take a quick tour over the main idea about this topic. As shown in this slide, there are only two key ideas. The first one is called factor theorem. The second one is remainder theorem. Let's take a quick tour. What is each of them means? The factor theorem. It was just given us if we have a polynomial of px and if x minus c is a factor of the function px, then we can take the root when x equals to c, and with that root, the x equals to c, and when we substitute into the polynomial, we will surely get the results of equals to 0, where indicating to us that there is no remainder. In other words, if we take the px, if we take this function, divide with this factor x minus c, you're going to have at the end of the division 0 remainder, and that is what factor theorem means. And I've given an example here. Given that if px equals to x cubed minus 6x squared plus 11x minus 6, and if given that x minus 3 is a factor, and that statement will pointing to us that x equals to 3 will be one of the roots for the px function. And in other words, if you take this cubic function and divide it with x minus 3, you are going to get some kind of probably a quadratic function, and you're going to have a remainder of 0. And that is what the factor theorem shows us. And therefore, to prove that, we have done here, taking from here x minus 3, we drawn out their root, which is x minus 3. Taking the 3, we substitute into the function. Therefore, accordingly, x cubed minus 6x squared plus 11x minus 6, and it will surely give us the end results of equals 0. And that is the quick overview of what is a factor theorem means. And let's go to the next key idea for this topic, which is called the remainder theorem. Using a similar idea, but provided that x minus c is not the function, it's not the factor, okay, it's not the factor of px. Then what it means? Then if we divide px with x minus c, you're going to get some kind of a function and the remainder of some value. So that is what it means. And for further understanding, I've shown it here. If p plus 1 is not a function to px, the example that we used just now, then from the x plus 1, we are able to draw out the value of x as -1. And if we show that this is not a factor, then you're going to show that x minus 1 is not one of its root. And therefore, if we substitute x as -1 accordingly into the function, and you will notice that you will have a value. For this case, it is equals -22 or -22, and that is the remainder as a result from, we will take the px divided by x plus 1. You're going to get some kind of a quadratic. Then at the end of it, you're going to get remainder of -24. And that is the remainder theorem. And it is something that worth bringing to our attention before we leave the quick revision, which is something that when whatever the statement was given for us to divide the cubic, when it is x minus 3, it is worth our attention. There is a sign change here. From the factor x minus 3, when we draw it into x value, it's going to be the opposite sign. So now for this case, from x minus 3, it turns into x equals positive 3. And again, it is shown here when the x plus 1, when we draw it into its x value, it is on the opposite sign that you get x equals -1. Well, that's all for the quick revision for this topic on factor theorem and remainder theorem. Now let's go to tackle this question. As we read the question, I have highlighted the key information that's going to be really helpful to us. Let's read the question. The expression x cubed plus 8x squared plus px minus 25 leaves a remainder of r when divided by x minus 1 and a remainder of negative r when divided by x plus 2. Assignment to us, part 1, find the value of p. Okay, now with the information given to us, we notice that there are two sets of information, and I have highlighted them in two different colors for our attention. The first set of information given in the sentence that when this cubic expression is divided by x minus 1, it will give a remainder of r. And that means if we were to take from here x minus 1, we know that we can draw out the value for x as x equals positive 1. And when with the remainder, we know that we're going to use remainder theorem. Therefore, with the x value as positive 1, we will substitute it into the cubic expression assigned for us. As I have put it here, this is the cubic expression given to us. And what we do is we will take the x equals to 1, now substituting accordingly to the cubic expression. And as the remainder theorem tells us that we're going to equals to r, which is given to us by the question. And from there, what we do is we simplify the equations after our substitution, and finally we arrive at p minus 16 equals r, and let's name it as first equation. And from the second statement, a remainder of negative r when divided by x plus 2. It's the same approach. From the divisor x plus 2, we draw out the x value. Remember, flip the sign. If x plus 2, then you draw out the x as minus 2. Again, because that is a remainder was mentioned to us, therefore, we're going to use remainder theorem also. Therefore, now with the x equals minus 2, we substitute accordingly. And then remember, the remainder theorem tells us that it will equals the remainder. And the question tells us the remainder is represented by negative r. Then we just put in accordingly. And what we do after substitution, we simplify the like terms and so on, and we arrive at negative 1 minus 2p equals negative r. Now we have obtained for ourselves, we have two equations. Okay, that's what we have here. Now let's take out this we will focus only on the simplified equation here. Then we know what to do next when you have two separate equations, and we're going to solve this simultaneous equation. And now we have seen there is something interesting here. The first equation points us to r. Second equation points us to negative r. So why not we take this r, going to conveniently substituting into this r, but carefully excluding the minus sign here. Okay, so that's what we're going to do, and I showed it here. You take the equation 1, substitute in equation 2, just copy down the equation 2, and then minus, as I mentioned here, remember to exclude that when you substitute the r. Then the r is what we have obtained from the first equation. We just put it into this position. Remember, it's minus r. Okay, then after the careful and accurate substitution, I'm sure the journey that follows will be much easier. You will just have to simplify and solve the linear equation with elimination of the r. Now you only left the p, and as you go on, that's how you conveniently arriving at p equals negative 17. All right, congratulations, we have done part 1. Let's move to part 2. Hence, find the remainder when the expression is divided by x plus 3. Now, of course, as usual, with the word hence is actually telling us using your answers from the previous section and to proceed with the current section. Therefore, as I have noted here from part 1, we have obtained the p-value, and therefore we're going to use back this p-value and substitute into the equation that they have assigned to us. Then you notice that there's a p here, so you just take your negative p, comfortably substitute into that, and this is how we get x cubed plus 8x squared minus 17x minus 25. And again, we have been reminded from the question the remainder. Okay, and they ask us to find the remainder, and surely, and of course, we will use the remainder theorem to find the remainder. And how do we go about it? The strategy is still the same. From the divisor x plus 3, we will draw out the x value that I have stated here. From x plus 3, we get the value of x as negative 3. With a gentle reminder again, flip the sign of the value inside the divisor. So positive 3 to negative 3. Now what you have done, you just take the x value, which is negative 3, substitute it accordingly into the cubic expression, and then this is what we do. Substitute them. -3 cubed plus 8 -3 squared minus 17 minus 3 minus 25. According to the remainder theorem, we are going to get the equating it to the remainder. And therefore, after all the successful substitution with the simplification, then you will surely know that in this place, you're going to get the remainder. You're going to get this as 71. And that surely is the accurate answer and the full mark answer for the remainder when this cubic expression is divided by x plus 3, and it will surely give you 71. And just to ensure that we get the correct answer, if you have extra time during exam, you can actually run a self-test. Let's just take that tour here. Okay, let's take the equation that we have obtained here and run the quick test. Let us take from here x cubed. Then just take this. And then let's put it here. All right. And what was the divisor given to us? Yes, they say x plus 3. That was the divisor. So this is not actually, from here onward, this is actually not part of the solution, but it is more for your self-checking and for your further understanding what is remainder theorem is about. Now, let's move on by long division of this whole thing. Well, x, we're going to get here x squared, and here you're going to add x cubed, then plus 3x squared, and less, you can underline as minus the remaining, what we have here, you're going to get 5x squared minus 17x. You go on dividing the next term, you're going to get 5x, then now you got 5x, then minus 3 times 5, you got positive 15x. Then we go on, when you minus that, we know that you're going to get 32x and minus 25. And let's go to the one last dividing of minus 32, then it will result for you minus 32x. And then plus that, you're going to get a minus 3 times 2 is 6, 3 times is 96. And let's go about that, and then let's go, and so minus 25 minus 96, and that's sure and true enough. That gives us, that is the remainder. So I hope that with this addition now information and the further proving with the long division, the remainder is 71, provided we take the cubic expression that was assigned to us with the p-value we have found in section 1, which is negative 17, and then we divide with x plus 3, and that ties up exactly as our remainder that obtained through remainder theorem. Well, congratulations, you have run through a quick revision and then the solution, and also you have run through the self-checking and the further long divisions for more detailed understanding of a remainder theorem. Okay, so we are done in this video. Looking forward to see you again in the next one. As usual, as always, happy learning. See you next time. Bye-bye.